Okay, people, I think we'll start the class. So this week, what we are going to do is take a look at a problem and related problems related to dynamic programming. So if you got a chance to go through this week's material on dynamic programming, so this problem will be helpful in understanding the concept better. So just read the problem. You have to in the whole crux of problem is basically finding the longest ascending sequence, so like the sequence that is increasing. And if you're given a random sequence, so in that sequence you have to find a subsequence in which each element is increasing one after another, and it should be the longest subsequence. Okay, and there's a way to do this problem using dynamic programming, like the algorithm. So and we'll be going through I think 4 or 5 problems, but they are all related to just this algorithm. So I'll basically give you a lot of time to just think on this problem and try to build an algorithm. Okay, and the algorithm crux of the algorithm is actually one of these options that you see here. So they have already, whatever is the answer is basically the main ingredient of the algorithm. So try to construct the algorithm yourself and see if it matches any of the options. And then followed by this question, we are going to look at other questions related to this algorithm itself, like its own complexity and the memory table that you'll have to store, those kind of questions. So just read the question carefully and try to build the algorithm, and try to basically run whatever algorithm you build, run in on the sequence that they have given, and see that do you get the resulting subsequence from it, like do you get the right solution. Okay, and if you have any problems understanding what the whole question or what algorithm we have to build, so ask right away, because otherwise the whole class would be wasted for you. So it's important to understand this question first for all other questions.
Hi Smith, I think if possible please discuss मतलब just एक बार एक क्वेश्चन को एक बार डिस्कस कर दीजिए और थोड़ा डायरेक्ट कर दीजिए. I've been watching videos of dynamic programming but थोड़ा सा इशू तो है.
Okay, so basically here you are given that, like, forget all the stock prices and the companies and whatever they are given. So here basically what you're computing is a function gp. All right, and now this gp function, it takes basically for every index, like if you have a sequence s given, so this s is your input, and it will have like 1 to n element, like 1 2 3 4 5 indexed 1 to n. These elements would be there in the sequence. So now when gp is called with an index, like here you're given gpj's, okay, that you have to calculate. Okay, so what this output of this would be is the longest number or sequence that you the longest sequence subsequence that you have, which is ascending in nature. So for example, this, if you are given this input s as in the question, like 20 23 6 34 22, and if you ask this if you call the function like gp, and the whatever index, like let's say the last index of 33 here. Okay, so the output is 7 here. Okay, and 7 corresponds to the length of the subsequence that we get, which is the longest ascending subsequence, and the subsequence will be 20 23 34 52 67 89. So these are the elements occurring in our original sequence s. Okay, like 20 is the first element, then 23, then we have skipped 6. Okay, because 6 will the sequence will go down. We only wanted to go keep increasing, keep going up. So we'll take 20 23, then we'll just drop 6, then we'll take 34, then 22 we are going to drop, we'll take 52, then 42 will drop, then 67 89 and 100. 5 and 33 we have dropped in between. Okay, so the subsequence that comes should be ascending in nature, and it should be the longest subsequence, ascending subsequence possible. So what you have to do in the whole question is try to figure out how would you compute this gp function, like how would you compute the length of the longest subsequence possible. And the formula for calculating gp is one of the 4 options given, like try to build the algorithm yourself first, and then see if that algorithm, like that crux of the algorithm, if it matches any of the options here. Okay. Rahul, you'll get your chance. Let others also think. I'll give you some more time to think, and then we'll look at the solution. Okay, should we discuss the problem, or do you guys need more time? Okay, I guess we'll discuss it. Rahul, I guess you can attempt your solution now.
We, as per the question, we have a list of list, and we have to extract the longest subsequence.
Mm-hmm.
Now, suppose we are considering that first of all, we have to calculate the growth potential up to j elements, and
Mm-hmm.
we are trying to find a recursive solution to
Yes.
it. So GPJ is growth potential for the prefix of stock prices ending at
Mm-hmm.
SJ. So we will not go up to n. We will just start from one first element to the jth sorry, jth plus one. Oh, actually GP1 is given, so there is no problem of indices. So we
Yeah.
will start from 1 to j. We will go from 1 to j.
Mm-hmm.
Now the argument goes as follows: either we will
Mm-hmm.
take the jth element, or we will
Mm-hmm.
not take the jth element. Uh,
Okay.
no, it's not out. I had forgotten what I was going to say. Max of j.
That is okay.
Actually, looking
Yeah.
at
Mm-hmm.
the first option, it seems to be correct. But later on, I felt that it is going to cost a lot of things. But the first
Mm-hmm.
option seems correct, because in it what we are doing is we are
Mm-hmm.
checking for all the elements up to j. If
Mm-hmm.
all the elements up to j are still less than the jth element, then
Mm-hmm.
what we will do is just keep the jth element, uh, and if all the elements up to the jth element are less than jth element, then we will keep all the elements up to jth element, else we will not. Actually, I think that I cannot explain. That
Mm-hmm.
was an intuitive answer. uh,
Okay.
I'm not cleared with dynamic programming, honestly. I'm just studying
That
it.
is okay. That is okay. We'll look at the solution. I'll tell
Yes.
you. Yeah. Anybody else want to attempt the answer? So GP is not exactly the array, but GP is basically the length of the sequence, strictly speaking. But apart from that, like, that is not the matter here. If you can just explain a recursive solution for either calculating the length of the sequence or the subsequence itself. Out of the 4 options, which one makes more sense?
Hello,
Hi.
can I give it a try?
Yeah, sure.
Yeah, so I'm not very sure, but then I think what we're doing here is at every index, I mean for every j, we try and find out the maximum length or the increasing subsequent length that we found till the jth element, till before the jth element.
Yeah.
And if that particular element has a value less than the present element, then we can add this element also into the increasing sequence with a much greater length.
Yeah.
So we do that for every index, and then we find the maximum positive length.
Yeah, that is correct. And according to that algorithm, then what would be the correct option? Out of the 4, what do you think is the correct option?
So the first one is doing that, right? So it is comparing all the elements before this and picking the smaller one and adding.
Yeah, that is correct. So the solution, as Vaishnavi said, it's basically looking at the longest subsequence that you have already found, and if you're on the jth element that you're checking for, so you compare this element with the longest subsequence you have found till now and see if this element is greater than the largest element of that subsequence. If it is greater, then you just append that into that subsequence and you add basically increase GP's value for that index by 1, because the subsequence, so it will be, if you, for an example, if we apply the same the first option that is given here, if we apply this algorithm to the given option S, okay, so we start with GP1 equal to 1, alright, and the whole dynamic programming business is if you have for a solution for an input, okay, now that solution, if you can only break down in terms of the solution for a smaller input, okay, and you can then recurse upon it. So for example, you are given here a sequence of n elements. Now if you can break the solution for n minus 1 elements, okay, and when you put that n minus 1, it will check for n minus 2, n minus 3, and it will just keep checking till it goes to just 1 element. Now you initialize for that 1 element because you do not want to recurse it infinite. It should have some halting condition. So GP1 would be that halting condition. If you are checking for a subsequence which has only 1 element, then that element itself is your subsequence and the length is then 1. Okay, now if for example here 20th, if we check for, then 20th would be that element itself. Now if you're checking for 2 element sequences, then it will be like 20, 23. So what we are checking in the first option is if this 23 is greater than like this sk will go from 1 to whatever index you're finding for. If you're finding for 2, then it will just go till 1. Okay, if you are finding for 3, then 1 and 2 it will check for. So this sk would then be just s of 1, which is 20, and 20 is less than 23, so you will meet this condition. Okay, and because now 1 would k would just be 1 here, okay, because it's 2 element sequence. So in max of GP1 you just have that GP1, so you'll, which was 1, so you'll just add 1 plus 1 2 here. Okay, essentially what you're doing is looking at the longest subsequence you have already found, comparing your current element with it, and if the current element is bigger than the sequence, then you're just appending this current element into the sequence. Okay, and this you will keep doing it till you find the solution for the whole n. So you start from 1 and then keep building for 2, 3, 4, 5 till you reach n, and the first solution is exactly that. The second solution is incorrect because it has sk greater than sj. So you're not checking, you do not want your current element to be less than, but the rest of the sequence you want it to be more than, so you can append it. The third and fourth sequence don't make any sense because they are comparing basically so what they are doing is they are also giving GP the value of 1 plus S j minus 1. So if let's say j is 2 or something here, so it is just 1 plus 20, which doesn't make sense. Basically there's no need to add the element of the sequence by 1. You get it? You just need to get the length of the thing. So what the exact numbers are don't matter. So third and fourth options are absurd in that sense. So your correct option is first one here. Alright, so that is the dynamic programming algorithm to compute this function. In case you didn't understand the algorithm or didn't understand the question, or you want anything repeated, just say now, because we are going to look at all the subsequent questions based on this algorithm only.
Sir, I got the solution, but isn't going to be expensive. I mean, when I come to the last element, it is going to compare the last element with the longest subsequent.
Exactly.
With every element of longest subsequent.
Exactly. Yeah. And we'll see actually a question regarding that. Yeah, but that is true. Like for any element that you are appending, you have to check with all the subsequences that you've gotten so far. Yeah, for all the indexes before.
This is one more question.
Yeah.
So can we say that here we're actually finding the maximum length of increasing subsequence which ends at that index j?
Exactly. Yeah. We are.
That's what we're doing.
Yeah. In sense, we are doing that. So, like, if we are looking for GP and whatever is the last index of this thing, I think it is 12. So, if you're finding like GP 12, which is like for 33, what is the greatest this thing? So, in some sense, the formula actually looks for the greatest subsequence which will end in 33. Yeah.
And then we have to traverse to the whole list again to find the maximum, right?
Yeah, so you can actually, for any index, you can keep saving. So we'll look at we'll look at the problem there, but then we can just output the maximum of the list. Yeah. Okay, so in case the algorithm is clear to everyone, we'll look at some questions related to the complexity of the algorithm. So the first question, as Vaishnavi pointed out, and Rahul also said, that we'll have to, it seems like an incremental wastage if we are doing it again and again. So a big solution for these kind of troubles in dynamic problem, like, see, the whole problem comes because you are looking for GP1, let's say, okay, and that is just one once you have initialized it. Now you look for GP2, so you are again looking at GP1. Okay, when you are looking for GP3, you are again looking at GP1 and GP2. So the thing is, once you have calculated these variables, it's a good idea to save them in a table, because you'll keep needing these variables again and again. And anytime a new variable is calculated for, like GPJ, so all the GPs which were calculated before that will be needed. So you can't just keep recursing again and again to get them. So as soon as you have calculated a new GP, just save that in a table. Okay, and this basically reduces the algorithmic complexity by a lot for dynamic programming, so that you have to compute for every thing only once rather than multiple times. So you always have a memory table. Okay, so what do you think would be the size of a memory table here? So basically you have to just think about calculating this GP, and we are calculating it for, let's say, this sequence. So you have to, and it's an n length sequence, so what you have to think about is what would be the let's say number of answers or subparts that you'll have to store in order to calculate your final GP value, like the whole thing. Okay, so if you have this algorithm in head, like this question just has 4 option n minus 1 n plus 1 n square. So I'll just put this algorithm here so you can just see what should be the size. So here what we are actually doing is if we are given an n length sequence, then we have to calculate GP1, then GP2, 3, and we have to calculate it for all 1 to n elements. Okay, and finally, as Vaishnavi pointed out, we'll have to, from this calculated GP1 to GPn, we'll have to basically find a max for the GP. Okay, so in that case, if we are calculating it for 1 to n, how many elements we'll have to store? So here we'll actually have to store all the GP1 to GPn if we need to find the max in the end out of that. So your correct answer is n elements. Like the people who are saying n minus 1, if they have a doubt regarding why did we store this element, we really don't need it. So you can ask if you have any questions regarding that, or if this is not clear, or if the concept of memory table is not clear to you guys, just ask. Okay, if this question is clear, we'll move on. Then we have to basically think about how would you like to compute the values of GP. Finally, you have to compute from 1 to n. Okay, and we have already looked at, like, one of you even said the order. Yeah. Yeah, so the order is from GP1 to GPn, and because we are initializing GP1 first, and then it's just easier to build up like from 1 element to 2 element, then to 3 element, because each new element you're comparing it with already built subsequences which are small in the beginning, so with only 1 element or 2 elements, and as you're growing it, you already have the answers that you'll need. So when you're calculating GPn, you already know the value of GPn minus 1, so you just need to add 1 to that if need be. Okay, so in that case, it's and in most of the dynamic algorithm, this is the pattern that you have to you start a solution from an initialization value and then just keep building a unit on top of that. Okay, fine. So the next question. So now this is the algorithmic complexity of the algorithm, and think about this carefully, okay, before answering, and just think about how many checks we'll have to do to calculate till GPn, and take even the memory table in account. Like, so every new calculated value we are storing it, so we have those, we do not have to recompute that. but just think about what would be the time complexity of this algo, and take your time on this. I'll give you some time for this. This can be a tricky thing. Just take your time, don't hurry with your answers. Just think about, and like as I always say, a better way to decide these things are actually running the algorithm on a dummy example. Just take a sequence of 4 elements. You already know the algorithm we have seen, and just try to run it on that and see how many steps you have to do. I'll just show you guys the algorithm again, and in terms of n, forget the options. Just in terms of n, think about if you're calculating, let's say, gpj or gpn, then how many steps do you have to do just to calculate each index? Is it of order 1, order n square? You have to just figure out the complexity of one step, and whatever that complexity is, you have to multiply it with n to get the complexity for the whole array. Just do it for an index, then multiply with n for the whole array. Okay, so look at what we are actually doing for any index here, gpj, let's say. So for example here, if we need to calculate gpj, we have an auxiliary index k here, which is going from 1 to j. Okay, and here for every element in 1 to j, we are doing two things. Okay, so we are comparing first if this sk is less than sj. Okay, and if that is the case, then we are keeping that GPK, that particular GPK in a set. Okay, and we will keep build this set for all the k's from 1 to j. Okay, and once this whole set is built, okay, then we are taking a max out of it and then adding 1 to it. Alright, that is the whole algorithm. So for each jth element we have to check for all the previous elements. Okay, so when we are on the nth element, we have to check for all the n minus 1 element. Okay, so for checking for each of the element is of order n. So we are doing it for an array with n elements, so it will be order n square. For each index it takes order n time, so for n elements it will take order n square time. Okay, so the time complexity of the algorithm is of order n square. If this is not clear to you, how did we compute it, or why is it should be that, then just ask right now. Okay, in case it is clear, so this problem is basically finding the longest subsequence in this given sequence. So rather than just doing it manually, what I want you to do is, you already know the algorithm now. Okay, so using that formula, just write a small code. Either you can write it in okay, there's a question on it. In the example shown, does GP contain GP1 equal to 1, 2, 3 equal to 2, GP4 equal to 3? Ram, what do you exactly mean by this? Are you saying what would be the saved values for each of the indices? So that you can actually check, and in relation to this checking, just write the algorithm from the formula given in the first problem. Make a Python code. Okay, just define a function which is recursing on itself, and initial value GP1 equal to 1, and just feed these the sequences that are given both in the first question to validate your algorithm. And if it is working fine on the first question, then just feed this question, the sequence given in this question, to your algorithm, and see what so this GP1 GP2 that Ram is asking, so that would be actually your memory table that you have to create. So if you have a sequence S of n element, then create a memory table for GP of n element, and as you are calculating each GP1 GP2 any new GP, if you have found the result, then just store it in a global array. Okay, now this GP will be a global array, so as the function is calling itself, the global table should still be visible to it. Okay, and just try to write this algorithm and find the answer for this sequence. I'm going to put the answer of this sequence also, like what are the longest subsequences here. So you'll find like two sequences of length 8, so these are given here. Finding the sequence is not important here, but able to code the formula into a program is important. So if one thing, we haven't done much coding in the tutorial sessions itself, so but I want to encourage you to just code this once by yourself, and Python would be very easy to code it in. Just keep a list of inputs and just keep going index by index and keep building your longest subsequences. So you'll get just basically a reference point for how difficult or easy coding can be from a given formula, and do validate that you are getting the right answers from your algorithm, like both for the first and this fifth question. Okay, and what Ram you are asking, like just check in that are you getting these values for GP, like GP1, GP2, GP3, like are these the values, are these values correct, or if you have any conflicts or doubts about it, like we can discuss it next time. You can show me a code, whatever you like. Okay. Okay. So I will not be able to copy paste the list because these were all in PDF forms. So what I'll do is actually put the slides in the same place, the directory that I've shared with you. I'll also put the recording today itself, so you have chance to attempt these questions. You can just, they are not such a long list, you can just open it and one tab and just copy numbers in another, and like it'll be fairly easy. Just try to write the code by yourself and check if you're getting the answers or not. And we can even if you have like a coding problem, like even though we didn't get much time to discuss, we discussed mainly theory, and that was the idea of the course also. Like it isn't a practical course, rather than it's a theoretical course. Like don't feel limited by that. If you just try to code this or any other coding problems if you have, we can discuss those also. So we have some time right now. Like I put some time in the end so that like some people had like some of the topics that are bugging them. So especially for the exams, if you're revising and you're finding some topics you do not still understand, so we can discuss them right now and we can go through them once again, and let's see if we can clear those doubts now. So if anyone of you have any things that you would like to just be repeated, we can do that now. Or any questions, anything you want to discuss about the course. Anyone? Any doubts? Any questions? How are you guys preparing for the exam? Is it going good? Or are you having trouble accessing the materials, or you have forgotten the previous things or anything? Do you want any help from my side or from the instructor side?
Hello sir, this is Shobna.
Yeah, hi.
Sir, this is the first time I'm attending this live class. So is there a way to access the earlier recordings?
Yeah, so I have the, okay, so are you on the WhatsApp group that is there?
Sorry sir, WhatsApp, some other group is there?
Yeah, so if you will go on discussion forum, so you will find a link for basically you'll find a WhatsApp link there. I'll just put the YouTube channel link here. If you want, you can just check it from there. But you can join the WhatsApp group also if you want. You'll find the link in the discussion forum.
Okay sir. Thank you sir. Thank you.
Yeah. Okay, so this is the YouTube channel link. You can access the previous week's recording here. There's also another sheet so basically if you'll go on discussion forum, I have posted there with a subject title called useful link. So there you'll find a Google Drive ka link. So in that Drive's link you'll find all the presentations also, and even the recording, like the MP4 files of the recordings. So that is another way to access the slides and the recordings from my sessions. Yeah.
Yes. Thank you sir.
Yeah. Anybody? Any questions? Any topics you want to cover? Okay, so we won't have a doubt clearing session on Sunday, but we can keep it on the regular time Tuesday next week. So next week what we'll do is we'll take some problems from the content of week 8, which is this week, and also like I want like if you those who are actually writing the exam, it's a good idea to revise it this week itself, and the revision won't take much time. Actually, you can just go through the slides individually and just look at the algorithms, either from from the slides, or just Google it, or from Wikipedia. You can just get the feeling of what the algorithms is, what would be the complexity of those algorithms. And if you have doubts related to any questions you have seen in quiz or in our tutorials, or if you just do not understand any algorithm, want to go over it again, then we can do that next Tuesday. So we'll do both of the things, but I want you to be more prepared with your questions for next week, and just revise it, because next week will be our last session. So if any doubts you have, just gather them till next week, and we'll go over them once. Okay?
Sir?
Yeah.
One doubt regarding exams, sir. Is
Mhm.
it like a multiple choice question plus programming also?
No.
Can you please tell me the format?
So that will be only multiple choice questions, like the ones that we have solved in tutorials and you have seen in quizzes. So the format will be exactly the same.
Okay, sir. Okay, sir.
Yeah.
Thank you, sir.
Yeah.
Hello, sir.
Yeah.
Yeah, can you hear me?
Yeah.
Yeah, this is not regarding the exam. I had one more question regarding the questions.
Okay.
So here we said that we have two sequences.
Mm-hmm.
So if we have to bit these sequences again, if the question is to find the count and find how many sequences are there of the count,
Mm-hmm.
can we use the same algorithm but actually keep track of the nodes and create a graph or something, and then maybe like a DFS or something?
So what you would have to do for this one actually is, I think if you want to actually also output the sequences, then for each of the index you have to have another sequence table for it. Okay, so let's say till the first sequence that it has outputted is the 6, 12, 21, 28, 33 until 71. Okay, now if we go till 71 is the last index here. Okay, now for GP, whatever is the index position of 71, if you are calculating GP for that last index, then it will give you one value which is 8, which is the longest sequence it has found, and it will give you actual sequence, which was the 6, 12, 21, 28, 33. And this you would have to basically as you are going, so I think like you actually try to code this one. It's an interesting question, and when you'll code it, there will be one step, like after checking all the conditions, you would be increasing your current GPJ to 1 plus some max or GP value. All right, now that increment point, that is basically your indicator that you have to keep that element in your sequence, at least for now. So at that point, whenever that all the conditions are met and the increment happen, that time you store that element into your longest subsequence for that particular index. But this was not such a memory efficient thing, because for each of the index, potentially like for n a sequence with n elements, you have to make n numbered array for each of the so n square space basically you'll consume. Yeah. But I think for outputting sequences, it has to be done that way, because for every index can have its own maximum subsequence. You get it? So yeah.
Right. Okay. Yeah, or we can maybe find the maximum length and maybe identify the index where it is occurred, and maybe in some way store the. So what I was thinking is I could maybe store the nodes that from where this max length, the +1 has happened, add some edges, for that node, and finally when I traverse and get the index where it is maximum, from that node I will do a DFS. I have a list of all the nodes it's connected to, so it will keep connecting and it will take me to the path. So this can happen maybe for either 3 nodes or 4 nodes. I have not tried coding. I will try it. But,
yeah, try it. It sounds like an interesting problem. And just see, like, if you are actually getting, like, if you would just talk about the algorithmic complexity of outputting the sequence also. okay, and see if that algorithmic complexity is getting better if you're using, like, constructing a graph side by side and doing a DFS on that graph. Yeah, but it's an interesting approach. I would like to see, like, if you whatever algorithm you get, like the complexity, if it's same or worse or better. Yeah.
Okay, sir.
Yeah.
Thank you.
Yeah. Okay, fine. If you guys have any more questions, ask now. Otherwise, we'll end the session here. And I'll see you guys next week. Do revise your slides, go through the questions, and if any doubts, confusion, clarifications you need, then we'll discuss it like next week, same time.
Sir?
Yeah.
Sir, how do I join the WhatsApp group? Is there a link in Neptal site only?
Yeah, so there in the discussion forum, basically you'll find a post by me. It has a subject called useful links, and that has a WhatsApp group link also, so you can join with that. Yeah.
Sure.
Yeah.
Thank you. Thanks.
Yeah.